Hello guys, so welcome to my YouTube channel again, and today we will be discussing the LeetCode daily for 6th of February, and the question number is 1470 and the name is shuffle the array. So I'll advise you to first go through the solution, go through the question and try a solution, and if you face issues then watch this video. I will be discussing two solutions here. One will be with extra memory and one will be in place solution. So, and since it is an easy problem, so I am directly explaining from code. Okay, so given an array basically nums and it is of size 2n, and you have to arrange it like this is the array given to you and you have to arrange it in this form basically. So here if it is x1, so it is of size 2n, so first n elements will be x and the last n elements will be the y's. So what you have to do, you have to bring this x1 along with this y1 together, then you have to place x2, then you have to place y2. So you have to bring change the format in this array and return this array. So I'll directly explain with example, and then in the example only we'll discuss how we get to the formula. Okay, so this is with extra memory. So we have taken an array answer which is of same size 2n. So this nums is of size 2n, so we have taken an answer which is also of size 2n. So we see that this is your array, this is your nums given to you, and this is the answer array which we are making, and I am taking the first example only. Okay, so the nums is 2, 5, 1 and 3, 4 and 7. So the x's are nothing but this is your x1, then this is your x2, then this is your x3, then this is your y1, and this is your y2, and this is your y3. Okay, so what you are supposed to do in the answer, you have to bring them together. So this is your x1, then this 3, this is from y1, so this is from y1, so this is y1, this is x2, this is y2, this is x3, and this is y3. Okay, so now if you observe here, when we are at even index, the even index is 0, 2 and 4. Then for the even index we have the x's x1, x2, x3, and the first x is at the 0th index, the second x is at the 2th index, the third x is at the 4th index. Okay, and from 0 we are moving to 2, from 2 we are moving to 4. So we are skipping one step basically, 2, 4, 0, 2, 4. So if you consider this, that 0, 2, 4, and 0 is having x1, 2 is having x2, and 4 is having x3. Now if you consider the position of these x's in the original array, x1 is at 0, x2 is at 1, and x3 is at 2. So you can directly see that if you divide this 0 by 2, you get this 1. If you divide this 2 by 2, you get 1. If you divide the 4 by 2, you get 2. So this divided by 2, this is the mapping that you have. So if you want to find in the answer, then in the original array you have to search the index by 2. This I am talking about for even index. Okay, this I am talking about for even index. So basically for I is equal to 0, I less than 2 into n, so I am just forming my answer here. So if it is even, then answer of I is nothing but nums of I by 2. So if you are in the answer, you are at the 0 position, you do 0 by 2, you get to 0. You do 2 by 2, you go to 1. You go 4 by 2, you go to 2. So this is basically it. So for the x's, it is very simple, that whatever is your x in the answer, whatever index is that in your answer, so this is your answer index. Okay, answer index. So how to move from answer index? So answer index mapping to nums index is for even index, it is nothing but I by 2. Okay, so this is the formula that we use. Now for the odd index, we see that 1 is having y1, then this 3 is having y2, then this 5 is also having this y3. So for the odd index, so odd index we have 1 3 1 3 and we have 5. So this is nothing but y1, this is nothing but y2, and this is nothing but y3. So yes, this is it basically. And if you consider the original or in the original array where this y1 y2 y3 are present, so they are present at 3 4 and 5 position. Now there is one thing, that if you subtract 3 from here, because these 3 elements, the y's are present at a distance 3 in this like after the x's they are present. So how many x are there? There are n x. So if you subtract a common 3 thing, you will get here, if you subtract from all these 3, you will get this. Here you will get a 0, here you will get a 1, here you will get a 2. So 0 1 2, basically you can, like it is saying like you can do indexing of this in this way: 0 1 2, because these x are separate, and after that we again have a different block: 0 1 and a 2. So from this 3 4 5, if you subtract a n, you again get 0 1 2. So this is that. And how to, so if we map from this to this, then adding a 3 will directly map this to this, because see, we have to map the indexes basically. From the answer index we have to go to the original index. So what I am doing is, from the, this is the answer index, these are your answer index, okay, this is your answer index. So if this is your answer index, I am first going from this answer index to 0 1 2. So how to go from 1 3 5 to 0 1 2? So you can see that they are just separated by 2 steps, okay, every time we take 2 steps. So what you do, if you do 1 divided by 2, it will be 0. If you do 3 divided by 2, then it will be 1. If you do 5 divided by 2, then it is 2. So dividing these indexes by 2, we get to this 0 1 2. And then if we add a 3, because earlier we subtracted 3, so in order to do the opposite operation we have to add a 3. So if we add a 3, so we go from this to 3, we have this 4, we have this 5. So how to go from this index to the answer index? So these 3 4 and 5 are the nums index which we wanted. So we divided by 2 and we add a 3. 3 is nothing but your n. N is given to you, okay, this nums is of size 2n, n is given to you. So see, for the answer of I, this else case means that it is odd. So it is nothing but nums of n plus I by 2. This is the formula, n plus I by 2, and this is how we get that formula, okay. So yes, this is it basically. This is just like finding the formula and just writing that formula down formally. Okay, so let me comment out this. So this is the basic code. This is just like, the code is simple. First create the answer of size 2n and then just iterate over this from 0 to 2n, and if it is even then apply this formula, if it is odd then apply this formula and return the answer. So let us check if it works again. Yes, so it is working, and you can see that like in terms of time complexity we are just, it is O of n loop, O of 2n loop basically. And memory, we are using extra memory, we are not doing it in place, okay, like we have created this answer array, okay. So this is it basically. In terms of time and space, basically we are O of 2n. 2n can be written as O of n, and in terms of time and space both, we have this complexity. Now suppose the interviewer says to optimize this, okay, that you don't have to do the changes in the answer. What you are supposed to do is you have to change this nums only and do the in place, this shuffling in place. Basically in the nums itself you have to do it, and you are not allowed to create any extra answer here, okay. So what, now this is the in place solution. So this is also very typical solution, which I think that you have to remember only. Like this is a trick basically, and you have to basically remember it. So if you don't get this in the first go, this in place trick, then don't be demotivated. It is a kind of a tricky solution basically. So the trick here is, see, if you look at the constraints on the nums of I, okay, nums of I is nothing but 1000. Okay, nums of I is nothing but 1000. So if if you don't know bit manipulation, then do not go through this solution. This question is purely based on bit manipulation. Like this in place solution is based on bit manipulation concepts. Okay, so you see that like this is 1000. So if you find like how many bits are needed to represent this 1000, so for that, if you consider, you just have to find the log of that, and you will see that you need, so just do log base 2 of this 1000, log base 2 of this 1000. So you just calculate the log base 2, it will give you something 9 point something, right? So basically you take the seal of this, so it is nothing but 10. Okay, seal of this is 10. So you need 10 bits to represent this number. Okay, this 1000 needs 10 bits to represent, but in integer we know that we have 32 bits. Okay, we have 32 bits. So what will happen, all the initial bits will be 0, and then starting from the from like the last 10 bits will be occupied. So some will be 0, some will be 1, but I'm just showing it is 1. So 1 2 3 4 5 6 7 8 9, and then so the last 10 bits will be 1, and the rest of the bits, all the bits will be 0. Okay, so from this 9 index all the way till the 0th index, these bits will be used by this nums of I, and the rest of the bits will be unused. So what we'll do, we have to store two arrays. Here we took two, here there are two arrays. Basically one array is the ans array and the one is the nums array. But since in the nums array we have nums array in every element of this nums of I, basically nums of I is occupying the first 10 bits only. So what you can do here, you can in the you want to store a answer array also. So what you can do, you can occupy these rest of the bits to store this answer array. Okay, you can occupy these 10 bits. Basically you are just shuffling, so you will just need this 10 more bits, and here there are like 30 more bits, here there are 20 more bits, basically specifically 22 bits more, but you just need 10 extra bits here. So what you can do, instead of creating extra vector here, extra vector of size 2n here, you can utilize this nums array only and store this answer vector in the nums only by using the bits from the position 10. So this is the position number 10 to the position number 19 to the 10. Okay, 19 to 10 you can use to store the answer at every index. So if I tell you nums of 0, in the nums of 0, the 19 to the 10th bit, like these 10 positions will store answer of 0, and from the 9th position to the 9th position to the 0th position, these 10 bits will store nums of 0, the original nums of 0. Okay, this nums of 0 is not the original one, this is the original nums of 0 that was given to you in the question. Similarly for nums of 1 also, from this to this, these will store answer of 1, and these will have the original nums of 1. So now the question is how to get from this nums of I. This nums of I is the modified, okay, modified, which is having 20 bits in use. and the first 10 are for answer of I. First 10 I am counting from the left, and the last 10 and the last 10 are for nums of I. So now the question is how to get the nums I original from answer or from nums I modified. This is the question. So I am saying, like, suppose take an example of 3 bits. Okay, suppose instead of 10 there are just 3 bits. So suppose 1 1 0 1 and 0 1 1 0. So these are 6 bits. So the first 3 bits are used for suppose answer, and the last 3 bits are used for the original nums. So this and the rest of the bits are 0 0 0 only. Okay, all the way 0 0 0, all are 0, and this is the number given to you. So how you will extract this 1 1 0? Because suppose we want the original value of num size. So how to extract this? What you can do is, see here, you create one mask. Okay, all will be 0 0 0 0 and 1 1 1, and see at these, because we wanted only the first 3 positions. So in that mask, a mask is nothing but a number. Okay, a bit mask basically is nothing but a number. This is a number with bit set at specific positions that we tell it according to our logic. Okay, so a mask is nothing but a number, but in that number we make some bit set and some bit unset according to our logic. So that is nothing but a mask. So we create another number, I am naming it as mask, and since we wanted the first 3 positions only, so what we'll do is, in that number at the first 3 positions we'll place a 1 1 1, and at the rest of the positions we'll do 0, and after that you just take the AND of the two numbers. So when you take the AND, so the 0 0 is 0, bitwise AND. At this position, since there is a 0 here, so it will not matter whether there is a 1 or 0 here, it will make it zeros only, because we have the property in bitwise AND that basically bitwise AND anything. So, say that there is a bit x, and if you take a AND with 0, it is 0 only. And at this position, since at this position all are having a 1, so what you can do here is, all are having a 1 and we are taking bitwise AND, so it will not matter whether what are you having here, since here it is a 1, so whatever is at the top, that will be just copied. So 1 and 1 is nothing but 1, 1 and 1 is nothing but 1, 0 and 1 is nothing but a 0. So here, since all are 1, so it will be just the above, because we have one more property for bitwise AND, that if there is a bit x and if you take a AND with 1, it is nothing but x, because here if it is 1, here it will be 1, here if it is 0, here it will be 0. Okay, so how to get this nums of I original from nums of I modified? You take a mask, at that mask in the first 3 positions you have a 1, and take the AND of the modified nums with that mask to get the original nums. Okay, so this is it. And how to get this mask? So if you wanted all like last 3 positions, okay, last 3 positions to be 1, so what you do, what is this number? This number is nothing but 1 1 1 1 1 1. If you tell in decimal, it is nothing but 7. Okay, and how to get this 7? 7 is nothing but 8 minus 1. This is nothing but 2 raised to the power 3 minus 1, and 2 raised to the power 3 is nothing but 1 left shift 3 minus 1. So if you want a mask of this size 3, Okay, if you want a mask of this size 3, then you just do 1 left shift I minus 1. 1 left shift 3. 1 left shift 3 is nothing but 2 raised to the power 3. And if you do a minus 1, it is nothing but 7. And 7 is having all the bits set. So this is one more property, that if you subtract from 2 raised to the power I, if you subtract a 1, you will get a number which is having the last I bits 111. Okay, last I bits equal to 111. This is also one property. So yes, this question is a bit tricky, and like you have to have a complete knowledge of bit manipulation for that. If you don't understand this, you can like in the comment section add that I want some tutorial, some help in bit manipulation, so I will make a video for that also. Okay, but here I am assuming you know all this. So yes, so this is it, how to get. So from the nums modified, you take a AND with 1 left shift 3 minus 1, and this is your original nums. So original nums of I, this you get from this. Okay, now the question is how to get these bits. So because like this we will need at the end only. Okay, this we will need at the end only. So what you can do, you see, now this is the second point, how to get these bits, how to get these 3 bits from this. These 3 bits are nothing but your answer of I, right? The first, like here 10, I am modifying it to 3, so here it is 3. So the last 3 bits represent the original nums, and the like these 3 bits represent the answer I. So how to get the answer I? So if like answer I is simple, so this is nothing but your nums I. So if in this nums I you just left shift it by 3 times, so what it will do, if you left shift this, you just take this and you left shift it by 1 time. If you left shift by 1 time, you will get this. If you again left shift it by 1 time, then you will get this. If you again left shift by 1 time, you will get this. So basically we have done the left shift 3 times. So if I take this original mask, like original number, and if I do a left shift of this 3 times, I will get this directly, and this is nothing but your answer of I. Okay, so how to get from nums of I to the answer of I? Just do a left shift by 3 times. Here we have taken an example 3, so whatever 3, just convert the 3 to 10 and rest of the things remain the same. So this is the bit manipulation logic that you will need to solve this question in place. Okay, so I'm just yes, now I am telling you the code, and like the code is nothing but this code is nothing but simple. Like we have, the code will be this only, but instead of just creating this extra answer array, I will be updating in the nums only. Okay, so yes, so first I create a mask. This mask is nothing but that only. Like here, if we wanted to create a mask of size 3, we would have done like this. If I wanted to create a mask of size 10, I will do it like this, and this is nothing but your mask. In the last 10 position there is a 1, and rest everything is 0. So yes, this is the mask. Okay, then see, I is equal to 0, I less than 2n, and this nums of I. So earlier we were having answer of I here, and we were having this formula nums of I by 2. Here we were having in the earlier solution the memory solution where we took the extra memory. Here we were having answer of I, and here we were having nums of n plus I by 2, just this. Okay, but here, since see, here take it step by step. Okay, first thing is that from this nums of I by 2, this nums of I by 2 may not be the original, this may be modified. So how to get from the modified to the original? this is original nums by 2, so I am storing it original. Okay, original is this. Since I have done it in a single line, it may be confusing, so now I am doing it like this. So this is the original nums of I by 2. How to get original nums of I by 2? I said that take the AND with the mask. Okay, take the AND with the mask. Yes. So take the AND with the mask and you will directly get the original. Okay, this is your mask, and if you just see how to get, this is your nums of I, the modified one, you have the mask, take the and you will get the original. Okay, so this is the original is equal to nums of I by 2. I by 2 is how I by 2 is coming, this I have discussed in this solution itself. Okay, this solution. So yes, so nums of I by 2 and mask. So this is the original nums of I by 2, and this is nothing but your answer of I. But here this is your answer of I. Okay, this is just your answer of I. But what is, we are not having answer of I here. We have to store it in nums of I itself. And I said that so in the nums of I, the positions from 19 to 10 are reserved for answer of I, and the positions from 9 to 0 are reserved for original nums of I. So I cannot change the original. So this answer of I, okay, this is nothing but your answer of I. This we have to left shift it 10 times. Basically earlier it is here, it is occupying this bit. Suppose this original, I am saying that this original is 11101. Okay, this and rest of the bits are all zeros. Okay, all are zeros. So here it is occupying the first 10 bits only, but we want this to occupy the last 10 bits. We want this to occupy the last 10 bits. Take an example of 3 only. Okay, here these are all zeros, these are zeros, and this is this is nothing but your answer of I. This is answer I. Okay, answer I is a variable that I am naming. So this is the answer I. Okay, this is the answer I, but I want to store this answer I in the nums I in these positions. Nums I is, suppose nums I is this. For this I, suppose nums I is 110. Okay, so if you look at nums I, it is nothing but initially there are 0 0 0 dot 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 0 0. These positions are filled with 0, and this is 0. This is your nums of I. Okay, let me bring it here. This is your nums of I, and this is answer of I. Okay, now what you have to convert the nums of I, you have to modify the nums of I from the original. You have to modify it to this, that initially all are zeros. Here I got 101 and here I have 110. This stores the answer of I and this stores the nums of I. So I want to bring this to this place in the nums of I. So what we do, we first shift all these 3 times to this place. Okay, we do answer I left shift 3 times. So what it will become is 0 0 0 0 0. Here we will have 101 and 0 0 0. So this is answer I left shift 3 times. And now if you take the AND of this nums of I and the answer I left shift 3 times, so if you take the AND of this one and this one, if you take the AND of this, then it will become this 101 110, and this is the modified nums of I. Okay, so what you have to do, answer I first left shift it 3 times. So I took the example of 3, but you have to left shift it how many times? You have to left shift it 10 times. So answer I left shift, left is equal to, so answer I left means the answer I am left shifting it. So this is nothing but answer I left shift by 10 times. And then what this is, this, like this and this, you have to merge the two. So how to merge the two? You can do, since here there is a 0 0 0 0 0 0, you can either take a or between the two, or you can also do a plus. That plus and or will have the same impact here, because at this position there is a 0, all zeros, at this position it is 0. So these 3 bits will not interfere with these 3 bits will not interfere with these. So either take a or take a plus. I am taking or here. Okay, so this is the nums of I. So this is the modified one. So we have calculated the modified, okay, modified nums of I. So here also I have just written it in one line. So answer I is equal to, this is the formula that we have, okay, n plus I by 2. This is from the brute force solution in the space solution, and this and mask we are taking to calculate the original nums of I. Then we left shift it is equal to answer I left shifted 10 times, and then we take the or of this with the, not the original, answer I left. So this will give you the modified, okay, this will give you the modified. And here how to go from modified to the original, like you have to now return the answer, right? Now you have to go from modified nums of I to the answer. So I have told you earlier also how to get from nums of I to the original. You just do a left shifted by 3 times, so you will just get this. So you just left shifted by 10 times and you store it in the nums, and then you directly return your nums. Okay, so this is it, basically, like too much of bit manipulation, but it is better to know, like bit manipulation is an important topic. So if you are completely thorough with bit manipulation, then only see this video, see this particular solution. The first solution is also fine, like in most of the interviews this will also work, but if you want to study this, study the bit manipulation way and study the in place way and how to store 2 numbers in a single number, then this problem is a good to go. Okay, so yes, it is accepted in samples. And yes, now we are better in terms of space also and in terms of time also. If you look at the time and space complexity for this, the time is O of 2n, basically O of n, and the space which we are using, we are doing it in place, so the space which we are using is O of 1. So this is it for this video, and these are the 2 solutions for this particular problem. It is a good question if you are like, it is an easy problem if you are considering the first solution, and it is a hard problem if you are considering the second in place solution. So yes, that's it for this video. If you like the solution, do subscribe to my channel, like the video. If you have any doubts, feel free to ask in the comment section, and if you have any demands for a particular video for a particular topic, you can very well tell me in the comment section and I will consider those. So yes, that's it for this, and see ya.